In C05, you mastered the fundamentals of Dynpro screens, creating screens, writing PBO and PAI modules, validating fields, and navigating between screens. Now we go further into the advanced controls that make professional SAP applications. Scrollable table controls for multi-row input, embedded ALV grids inside screen areas, split pane layouts with 2 panels side by side, image display, and non-ABAP customization tools like BAdIs and screen variants. By the end of this module, you will be able to declare and use a table control for scrollable multi-row input on a screen. Embed a CL_self_grid ALV inside a custom container area using the create once pattern. Build a split pane layout with CL_G_splitter_container. Display images with CL_G_picture. Implement a BAdI to add custom logic at a SAP enhancement point. And create screen variants with SHD0 to simplify screens for specific user groups. Transition, we now move into the embedded screen controls, table controls, ALV grids, splitter containers, and picture controls. Each of these brings a richer interactive surface to a Dynpro screen than plain input fields. Over the next 4 slides, we will cover declaration, the create once pattern that all GUI controls share, and the typical layout patterns. A table control is a scrollable, multi-row input area on a screen, like a small spreadsheet embedded in a dialog. Users can view and edit multiple rows, scroll vertically, and resize columns. Think of it as a simple editable grid. Declaration. In your program, controls TC_lines type table view using screen 0200. This declares a special work area TC_lines with fields that control the table scrolling state. In SE51, place a table control element with the same name. Add column headers and fields linking to your row structure. In the PBO flow logic, the loop uses with control TC_lines cursor TC_lines current_line. This tells SAP which rows to display for the current scroll position. In the display module, copy the current row from your internal table using the current_line index. In PAI, a matching loop collects updated rows back into your table using modify with the index. The key field TC_current_line tracks which row of your table the loop is currently processing. Always use it as the read table and modify table index. To embed an ALV grid inside a screen, place a custom control element in SE51 and give it a name, for example ALV_container. In your PBO module, create a CL_GUI_custom_container passing that name as the container_name parameter. Then call CL_ALV equals factory passing the container as R_container. The critical pattern is create once. Check if go_container is initial before creating. If it is already created, on the second and subsequent PBO calls, just call go_grid- refresh to update the display with the current table contents. Creating the container on every PBO call causes memory leaks, flicker, and eventually a program abort. The container_name must match the custom control name in SE51 exactly, including case. This is the most common error with embedded controls. A name mismatch gives a runtime error saying the container was not found. CL_GUI_splitter_container divides a parent container into a grid of panes. You specify the number of rows and columns. Then call get_container passing the row and column coordinates to get a container reference for each pane. Each pane is a regular container where you can place any GUI control, an ALV grid, a text editor, a picture, or even another splitter for nested layouts. For a typical master detail layout, 1 custom container on the screen, 1 splitter with rows equals 2 columns equals 1 inside it. Top pane for the header ALV, bottom pane for the item ALV. Set the row heights with set_height, passing a percentage for each row. When the user clicks a row in the top ALV, the link_click event handler reloads the item table and calls refresh on the bottom ALV. CL_GUI_picture displays images inside a custom control area. Create a container, create a picture control parented to the container, set the display mode, fit_center scales the image with aspect ratio preserved, then load the image using load_picture_from_memory. Images can come from the MIME repository in SE80 or be stored as binary data in a custom table. The 4 display modes on this slide control the scaling behavior. Fit_center scales to fit while preserving aspect ratio and centering. Fit stretches to fill the area while preserving aspect ratio. Normal renders at actual pixel size with no scaling. Stretch fills the area ignoring aspect ratio. All SAP GUI controls descend from CL_GUI_control and attach to a container. The 4 most important container classes shown here: CL_GUI_custom_container attaches to a named custom control element on a screen, the entry point for every screen embedded control. CL_GUI_container docks to a screen edge, top, bottom, left, or right, without needing a custom control element. Useful for persistent side panels and status bars. CL_GUI_splitter_container divides a parent container into a grid of panes. Each pane itself a CL_GUI_container ready for further embedding. CL_GUI_picture displays bitmap, JPEG, or PNG images inside a container, with display modes controlling the scaling behavior. Transition: we now move from the embedded GUI controls into the enhancement layer and the variant layer. BAdIs let you inject custom logic into standard SAP code at predefined extension points without modifying the original program. Screen and transaction variants let you simplify the user interface for specific roles without writing any code at all. Together, they give you 2 powerful tools for tailoring SAP behavior while staying on the supported upgrade path. The grids and utility classes on this slide complete the GUI control reference. CL_SALV_grid is the modern object-oriented embedded ALV, preferred for new development. Instantiate via the factory method passing the container. Call refresh after data changes. CL_GUI_ALV_grid is the older classic ALV grid. More complex API, but the only choice when you need inline editing in an embedded grid, because CL_SALV_grid is read-only. CL_GUI_TextEdit is a multi-line text editor with an optional toolbar, useful for long text capture. CL_GUI_frontend_services is not a visual control at all. It handles file upload, download, the file selector dialog, clipboard, and directory listing on the user's PC. BAdI stands for Business Add-in. It is SAP's standard mechanism for adding custom logic at predefined extension points in standard SAP code, without modifying the original program. When the standard code reaches a BAdI call point, SAP automatically calls all active implementations of that BAdI. The process has 4 steps shown on the slide. Find the BAdI using SE18 or the enhancement workbench. Examine the interface to understand which methods are available and what parameters they receive. In SE19, create an implementation for the BAdI, giving it AZ name and assigning it to your package. Implement the interface methods in the generated class. Finally, activate the implementation. This is the step most commonly forgotten. An inactive implementation is silently ignored. In each method, you receive the standard data as parameters, typically read-only, and return either messages or modified data depending on the BAdI design. Screen variants, created in transaction SHD0, let you simplify standard SAP transactions for specific user groups without writing any ABAP code. You run the target transaction in recording mode. Then, for each screen, specify which fields should be invisible, which should be read-only, which should be mandatory, and what default values to prefill. Save and activate. To deploy a screen variant, create a variant transaction code in SE93 that points to the base transaction with your variant active. Assign this Z transaction code to the relevant users. They see only the fields relevant to their task, a dramatically simpler interface. The 3 columns on this slide walk you through that flow end-to-end. 2 tools, different scopes. A screen variant modifies the screens of an existing transaction, applied to the original T-code, hiding fields and setting defaults per screen. A transaction variant goes 1 step further and creates a new named Z transaction code with the variant embedded. Useful when you want a simplified entry point for a process, for example, a warehouse PO creation T-code with hidden fields and pre-filled plant. Authorization. Both inherit from the base transaction, and transaction variants can additionally be restricted via auth objects to lock the new entry point to a specific user group. The decision is simple. If you want a new T-code for a user group, use a transaction variant. If you want to modify how an existing T-code behaves, use a screen variant assigned directly. BAdIs come in two flavors that coexist in modern SAP systems. The classic BAdI, defined in SE18 and implemented in SE19, is filter-based, single-use or multi-use, and still dominant across ECC custom code. The new BAdI sits inside an enhancement spot in the enhancement framework, switchable via the switch framework, with filter expressions evaluated at runtime, and is the preferred choice on S/4HANA. Choosing between them, read the BAdI documentation in SPRO before implementing. If the enhancement spot is new style, use the new framework. If you are touching ECC custom code, follow the classic pattern already in use. For advanced Dynpro mistakes, first, creating the GUI container on every PBO. This duplicates objects in memory, causes flicker on screen, and eventually crashes the session. Always check IS initial and create only once. Second, container name case mismatch. If the custom control in SE51 is named ALV_container but your code passes ALV_container, the control is not found. The error message says the control was not registered, which is cryptic. Check SE51 and match exactly. Third, missing with control cursor in the table control PBO loop. Without the cursor, SAP cannot know which rows to display for the current scroll position, so the table shows data but scrolling is broken or displays wrong rows. Fourth, BAdI implementation not activated, the most common BAdI debugging scenario. The developer implements the method, tests, and sees no change because the implementation is inactive and SAP never calls it. Always check activation status in SE19. Table controls. Controls type table, PBO loop with control cursor, PAI loop modify. Embedded ALV, create once pattern, IS initial check, go_grid dash, refresh for updates. Container_name must match SE51 exactly. Splitter containers, rows x columns grid, get_container for each pane, set_height for proportions. BAdI, find in SE18, implement in SE19, activate, always activate. Screen variants, SHD0 for hiding and defaulting fields, variant transaction for deployment. Transaction variants create a new ZT code wrapping the base transaction with customized screen behavior. Your lab builds the Acme PO display, a Dynpro screen with a splitter container, vendor list ALV in the top pane, and PO list ALV in the bottom pane linked by click selection. Good luck, and I will see you in C07, ABAP Object-Oriented Programming Part 1.